Okay, take 10. My name is Douglas Hill. This is going to be my Module 2 demo video. For this project, I've decided to go with the Kotlin programming language. I've written a notes taking system that allows a user to do most of the general file management things you can do in a command line, like creating a directory, creating files, deleting directories, um, appending to the files, all those kinds of things. Um, I'm going to just show you the menu that I've got. So first off, you can search a file for a word. You can just make a directory. You can change the directory. You can search the directory for a word. You can read the contents of a file. You can create a new file, append to a file, delete a file, delete a directory. You can list all of the files in a directory. You can quit the program, or you can display the command options again. The menu logic is done with the Kotlin when keyword. It's basically a case statement for this. So it's looking for these keywords and then just executes whatever code belongs with that. So pretty straightforward menu. Um, my current directory is just being held as a string. So when I change the directory, all it's doing is changing that um, to whatever argument is being called in. So um, it's pretty straightforward. All I'm going to do is take um, at the menu level, I'm going to get user input, and I will go over this in just a second, but it'll get back an argument, and then it will just change that to whatever the argument is. So anytime any of these options call for a directory, it just passes it automatically. Pretty straightforward. Not too complicated there. Most of these files or functions, I should say, are very straightforward. Um, they just a lot of them are going to delete's a little more complicated. Most of them are going to be building a file path, building a file object, um, and then just doing different things with the files. So they're not the most exciting things. The ones I wanted to go over are my parse input function. This guy takes a user command input as a string and returns a triple of strings, which is essentially a 3-element tuple, but they call it triples in Kotlin. I have a nested function that counts the number of spaces inside of a word by stepping through the characters in there and incrementing an integer for every time it finds a space. That's returned down here. First off, I'm going to do is I check the word to see whether or not it actually has a space in it. If it doesn't have a space in it, then it means it's just a single word and it doesn't do any of this. It just passes it right back out. But what it does do is it passes a null and a null for the other two, and those are not used in that spot where this is actually being, where that's actually being called. If I do have spaces, if I have one space, then I've got two words. If I got two spaces, I've got three words. I could go further than that, but I don't need to. So if I got one space, it splits the word into two, a list of two strings. It makes a command and a file name string. Command grabs the string at index 0. File name grabs the index at, or it grabs the string at index 1. And then it returns the triple with the command and file name strings, and then just returns null for the argument. And then the same thing is done down here, but it splits it into three words. So that's how I parse. And you'll see the commands I have to put in here when I actually do the actual demo. So the other two that I wanted to talk about primarily were my find word in file and my find word in directory functions. So this guy takes a file name as a string, takes a word to find as a string, and it takes a directory. So first thing it's going to do is it's going to get a list of all files in the directory, and then it's going to check to see whether or not that file exists in that directory. If it doesn't, then it's going to pass everything by and just print out the file doesn't exist, and then it's going to quit. And you can just go back to the menu. automatically. If the file does exist, we're going to we're going to read the file as lines. So we're going to get back a list of strings. And then we're going to first, before we do anything else, create a Boolean for word found, set it to false. And then we're going to step through each of um, the the lines in the file, and that's our outer loop. And then we're going to step through each of the indexes or the characters as indexes. So we're going to step through 0, 1, 2, 3, 4, all the way through whatever how long the string is. um, and it's going to check each one of those indexes. So what it's going to do is, for index 0, if index 0 is an A, and let's say the letters after it are B and a C, if I'm looking for it's going to make a substring of those three letters, and then it's going to come down here and check to see if ABC is equal to the. Obviously, if it isn't, then it won't execute any of this, and it will go past this and start this inner loop over again. If it is equal to it, after I've done a check here, that basically makes sure that I have more letters left in the word at a given point there are than the size of the word. Um, what that is important for is here, where I'm checking to see if there's a space before the word and a space after the word. If I check for a space after the word and the word happens to be the last in the string, then it will throw an out of bounds indexing error. So it's important to check this. So this assumes that the word is not at the end, and this assumes that the word is at the end, and only looks for a space at the beginning. Um, if I don't do this, then it's possible that the function will find a word embedded inside of another word. Example being the word another has the inside of it, so it would return the line having said I found it, but it may not actually have the in it because it's embedded inside of another. With this, it will return the word or return a sentence that has the in it. So that's how I find words in a file. When I'm finding words in a directory, I simply make a list of files in a directory and I step through each of the files in the directory. The first thing I do is I find the period in that file name so I can get the index of it and create a substring so I can tear off the extension because I don't expect the user to want to type in txt for everything. And then it simply takes these arguments it's creating and calls the find word in file. So it'll say checking this file, found this. Checking this file, found nothing. Checking this file, found this. And you'll see that in just a second when I do the demo. Again, everything else is just very straightforward. Create a file path, build a file object, do a thing with it. Not really worth talking about. So I'm going to go ahead and do my demo. So again, I can search a file for a word. I can make a directory. I can change to a different directory. Search a directory for a word. I can read the contents of a file, create a new file, append to a file, delete the file, delete the directory. I can list all the files in a directory. I can quit the program, and I can reprint the display command options. So in text files, I want to just really quickly demonstrate the search file option. So I have a pre-built file that I made. Um, has a lot of lines in it. So I'm going to search file for the word the. Whoops. So I searched the file the. I'm going to search file test. So search file is a command. Test is the file name. The is the word. This file happens to have the in every single one of them, and they're just randomized sentences. So I'm going to do the same thing again. I'm going to look for, let's say, them. Had one line. Do the same thing again. Let's say, did it again. Search file test. See, that had 5 lines. So you can see how it fairly efficiently finds all that kind of stuff. Um, I don't have multiple files like this built up in this main text files default, but I can do search dir as the, and again it pulls up everything in this one. I have another one that another demo file from a different attempt to make a video, but that file happens to have two lines that have the word the embedded inside of it. So that's the search file and the search directory. Let's see. So search file, let's go ahead and make a directory. So I'm going to make a directory as, and this as is not important. It could be Timbuktu. All it is a placeholder for that file name argument that we're not actually using here. If I tried to do it otherwise, it would break the program. I feel like I got pretty fairly robust error handling, but I can always use more error handling. I think that's one of those things. So I'm going to make dir as demo dir. So I make the directory. I don't necessarily automatically go to it. So I'm going to change my directory to demo dir. And you can see here I'm now in demo dir in the menu there. So I'm going to make a new file, and we're going to say demo file. So it made demo file. It'll switch to demo file and start editing that file. So just for funsies, this is the first line. This is the second line, and I love programming all day long. So now that that's built, um, when I'm editing, as you can see, that's all I can do is edit. So I have to quit to back out to the menu in the demo dir and directory. So now I can say, let's read my demo file. I can read all the different things that I wrote in that file. Let's go back and make sure making sure I'm covered everything. So I searched the file, I made a directory, I changed to a directory, I searched the directory, I read the file, made a new file. Let's append to the file. So I'm going to append demo file. So it's essentially going to go back to where I was when I created the file. Another line, yet another line. I go back. You can see I added more lines to it. Let's see. New file, append. I'm going to delete. Oh, let's get my fingers in the right places. Delete file, demo file. Boom. So demo file has been deleted. If I list all, it will show me I have no files in this directory anymore. Um, I've showed you the help command several times, so I can. The only thing I haven't done is delete a directory yet. So I'm going to delete the directory that I'm in. So what this does is it first checks again that the directory exists. If the directory doesn't exist, then it will tell you that you've done something wrong. If you're in the active directory, it will kick you back to the main default directory. And if I attempt to delete that, it will check for it. It'll say directory. Wait, what? Oh, text files. Delete text files. It will tell me that it cannot delete the default directory. However, if a person wants to go in and manually delete it, the program will create that directory when it starts up. So that is all of the functions that are in my program, and that is it.